Hi, welcome to the video for question 15, 16, and 17. So I'm not going to do these on paper, but I will do these with the periodic table. So 15 asks, write the electron configuration, noble gas configuration, and orbital notation for the following elements. Alright, so we have phosphorus, number 15. So phosphorus is here. Well, to do electron configuration, I need to start at the beginning. I'm going to start in period 1 in the S. So S can hold 2, so that's hydrogen and helium. So that's 1s, and both of them are filled, so that's 1s2. Then I have 2s, period 2, so both of these are filled, so it's 2s2. And then I move over to the P. Now I have 2p, and I have to fill them all the way up to phosphorus. So I have 1, 2, 3, 4, 5, 6. So 2p6 is filled. Then I have to go to the next one, to 3. 3s2 is filled, and 3p1, 2, 3 would be filled. So let me just write that down, I guess. Be a little bit easier. So I went from 1s2 to 2s2 to 2p6 to 3s2 to 3p1, 2, 3. So that's the electron configuration, because here I have hydrogen, helium, then lithium, beryllium. That's the next two. Then I go from boron all the way to neon with 2p. Then I do sodium and magnesium. Then I do aluminum, silicon, and phosphorus, and end up there. This really helps if you have a periodic table in front of you. Now, the noble gas notation should be the noble gas before the element. So I have phosphorus. The noble gas before phosphorus is neon. So I would put neon in brackets. And then by putting neon in brackets, I'm saying everything up to neon is true. So I'm going to go and just continue. So then I have neon here, then I have 1, 2, 3, 3s2, 3p1, 2, 3. So I'd have 3s2, 3p3. And if you notice, the noble gas configuration and the electron configuration are the same thing, because this is the configuration for neon. So let's move on to, let's say, potassium. I don't want to do the whole electron configuration for potassium, but I can definitely do the noble gas configuration for potassium. So potassium is here, number 19. So the noble gas before would be argon. So I would do argon, Ar, and everything up to argon is true. So then I would just move over here. So it's 1, 2, 3, 4. It's in period 4. It's in the S, and there's only one. Let's be 4s1. That's all I'm going to do for 15. Let's look at 16. For each of the following groups, what ending electron configuration do the elements have? So for group 1, they would end group 1 and 2. They are in the S. So group 1 would end in something S1, and group 2 would end in something S2. So group 1 would end in S1, and group 2 would end in S2. So group 13. All the way through 18. We would have P, because group 13 through 18 are in the P's. So it would go from P1 all the way to P6. The transition metals. Now, transition metals, you must remember you're going to subtract a number from the period. So if you're here, you're in period 4, you're actually going to be in 3D. So you would be in D1 all the way to D10, but you must subtract 1 from the period. So if you're in period 4, you would be in 3D. If you're in period 5, you would be in 4D, and so on and so forth. Then we have the lanthanide and actinide series, and those are 14 in the F orbital. So you're from 1 to 14. Sorry, from F1 to F14. Geez, F1 to F14, and these are your period number minus 2. So if you're in period 1, 2, 3, 4, 5, 6, you would actually be in F4, and if you're in period 7, you would be in F5 because you're subtracting 2. Alright, now question 17. Explain the contributions of Mendeleev and Moseley to modern periodic table arrangement. Well, Mendeleev gets a lot of the credit. This is the last question for this video. Mendeleev gets a lot of the credit for the periodic table, and that's because the way he arranged the periodic table is he left empty spaces for elements that had not been discovered yet, but he was sure would be discovered following the trends that he was noticing in the periodic table from the groups. So he knew that every so often there would be elements that would repeat and have similar characteristics, and he was the first person to do that. Then we have Moseley, and Moseley did something pretty awesome. And Moseley arranged the elements by atomic number and not atomic mass. So atomic number has made it easy for us to go from 1 to 118 without skipping a beat and not have any of this weird, yeah, this one's a little bit heavier, but actually it has less protons. So Moseley said, number of protons, that's the element we're talking about. And Mendeleev was like, hey, there's probably going to be one here, just you wait. Alright.